The body must have glucose available at a steady rate all day. As we've already discussed, all cells and tissues in the body require carbohydrates for use, so this steady stream or steady availability is very important. The body itself cannot use polysaccharides or disaccharides, and even the monosaccharides of galactose and fructose the body can't use directly. It needs to use glucose. So how do we get from being a full-on carbohydrate to glucose that's available for our cells and tissues in the body to use? That is the topic of our third video segment this week. So digestion of starch begins in the mouth, where salivary amylase splits the starch into shorter units. So remember that starch is a polysaccharide, and anytime you see the word amylase, this is going to indicate to you that it's related to an enzyme related to carbohydrate digestion. There's no digestion of starch or really any carbohydrate in the stomach, but digestion of the starch will resume in the small intestine by the action of pancreatic amylase. So again, amylase indicating that it has to do with starch or carbohydrate digestion. So the pancreas, which is another accessory organ, is producing amylase, which will be sent from the pancreas to the small intestine, where carbohydrate and starch digestion will continue. Starches really do break down at different rates. So, we talked about how complex carbohydrates and starch takes longer to break down than, say, a simple carbohydrate. So refined white flours break down very quickly. Beans are digested more slowly, and then resistant starch may not be digested at all. So it's similar to a fiber, but it's referred to as a resistant starch. Looking at sugars now. So disaccharides are split to yield the monosaccharides. So remember that the body requires that all those disaccharides be split into the monosaccharides. The monosaccharides can be absorbed directly into the blood. So different enzymes on the small intestinal lining will break down these disaccharides. Once the monosaccharides, we have our monosaccharides, they will be absorbed directly into the blood and they'll travel to the liver. And then the liver will convert galactose and fructose to glucose. The circulatory system then transports the glucose to all cells, and the liver may store some glucose as glycogen. And remember that glycogen is really that branch chain of glucose molecules. So glycogen is our storage form of glucose. Fiber, again, cannot be digested by the human body, so we don't have any enzymes that will do that will break down fiber, but it is fermented by bacteria in the colon, so this can cause some odorous gas. So we talked about the things that we need to do as we add fiber to our diet, including, having adequate fluid intake, not consuming too much at once, and consuming our fiber intake throughout the day. So while we're on the topic of some sugar digestion, let's talk a little bit about lactose intolerance. So individuals that have trouble digesting milk may be lactose intolerant. A lot of people may think they're lactose intolerant, but the only way that lactose intolerance can truly be diagnosed is through a test like at a doctor's office. So the ability to digest milk carbohydrate or lactose varies, but when there's the inability to digest the milk carbohydrate, this is due to insufficient production of lactase. And lactase is the enzyme that breaks down lactose, and it's made by the small intestine. As individuals age, lactase production decreases. So with age, you may have greater inability to tolerate milk products. Certain ethnicities and races also have a higher likelihood of being lactose intolerant. These include African American, Asian, Hispanic, Indian, and Native American. So some symptoms of intolerance might be something like having nausea, pain, diarrhea, excessive gas. These can be managed, which we'll talk about some strategies in a moment. But there are nutritional consequences for cutting dairy completely out of the diet. So dairy, it is providing us some carbohydrate from the lactose. It's also providing important things like calcium and potassium. So if dairy products are not consumed, it's very important to find alternative sources of calcium. As far as milk tolerance and strategies go, again, the tolerance level will vary among individuals. So some people can't tolerate anything with any dairy, and some may be able to tolerate more processed items. So something like yogurt or cheese, they can tolerate better than just flat out milk. Some other strategies might include choosing, lactose-free products, or consuming the regular milk products, but also taking lactades, which basically act as lactase to help break down lactose in the body. Also, you should choose calcium fortified products if you're not able to consume dairy products, because calcium is very important for strong bones and for other functions in the body as well. So definitely important to get your calcium. So calcium fortified things, you can find a lot of different products. So orange juice is going to be fortified with calcium. A lot of cereals may be fortified. So definitely check the packages of things to see what has been fortified with calcium. Let's also talk about gluten-free while we're on the topic of lactose. Not necessarily related, but gluten-free has to do with carbohydrates. And first, gluten is a protein composite that consists of gliadins and glutenins, and it's found in wheat, barley, and rye. So you're probably thinking, why are we talking about proteins and we're talking about carbohydrates? But this protein is found in carbohydrates of wheat, barley, and rye. So these are the carbohydrates. So gluten-free is related to carbohydrates and not protein, other than gluten itself is a protein. So individuals who have celiac disease or have gluten sensitivity, these are the individuals that should follow a gluten-free diet. So this means we want to choose products that are not made from wheat, barley, or rye, or anything else that may have gluten. So a gluten-free diet really focuses on fruits and vegetables, beef, poultry, fish, nuts, eggs, rice, corn, beans, and quinoa. All of those are naturally gluten-free. You do have to watch for cross-contamination. But gluten-free doesn't equal healthy, and I think this is also a common misconception. So gluten-free items may be deficient in whole grains, because think about this: if they can't eat wheat, how are they getting their whole grains? So they would need to choose an alternative whole grain like quinoa that does not contain gluten. They could also be missing out on other important vitamins and minerals. Individuals that actually do have celiac disease, the villi and microvilli in the small intestine can actually be damaged by consuming gluten, and so the absorption of vitamins and minerals within the small intestine will decrease because of that damage to the microvilli. So if you have celiac disease, it really is important and pertinent, necessary to avoid gluten. But if you can tolerate gluten and you don't have the allergy, then it's not really necessary to follow a gluten-free diet. And there's really no evidence to suggest that following a gluten-free diet has any significant benefits for the general population that can tolerate gluten with no problem. As we've already talked, glucose is the basic carbohydrate unit used for energy, and it's the preferred source for all of the tissues and cells in the body. Glucose can be converted to fat, but fat cannot be converted back to glucose. And the dependence on protein when there's insufficient carbohydrate is due to the protein-sparing action. So we've already talked a little bit about how it's a lot of work for the body to use protein for energy. So again, this is why we need carbohydrates. When there's too little carbohydrate intake, this can cause ketosis, which causes a shift in the body's metabolism and this disruption of the acid-base balance. So this can have some serious consequences, but really is caused from excessive long-term low carbohydrate intake. So therefore, the DRI for the minimum of digestible carbohydrates that should be consumed each day is 130 grams. We've already talked that this is the necessary amount needed to feed the brain, provide energy for the brain, and to prevent ketosis. This picture does a nice job, and this is from your textbook, showing blood glucose regulation. So remember, the pancreas is a accessory organ, but it's a gland because it produces hormones, so two of these hormones being insulin and glucagon. So insulin is going to signal the body tissues to take up glucose. So, we ate a sandwich with whole grain bread, and that has glucose in it. So the glucose is in our blood. So for our cells to pick up that glucose, insulin is going to be released from the pancreas. This also causes the muscle and liver cells to convert glucose to glycogen for storage. When we go through a period where maybe we haven't eaten anything and our glucose gets a little bit low in the blood, then glucagon will trigger the breakdown of glycogen to release glucose into the blood and to raise blood glucose levels. We've talked a little bit about glycogen storage. So glycogen is the storage form of glucose in the body. You can see the main storage sites here. So muscles, 2/3 of our glycogen is stored there for physical activity. The brain, it's stored there for emergency, but the brain likes to use glucose, have it on. It's one that requires the steady rate of glucose. And the liver is going to store the remainder of glycogen. Our stores are not, long-term stores. So if you didn't eat any carbohydrates, these stores can be depleted in less than a day. So again, this reinforces the concept of having a constant intake of not only food in general, but definitely carbohydrates. And then glucagon will stimulate the breakdown of glycogen into glucose whenever blood glucose levels are too low. Again, the AMDR for carbohydrate intake is 45 to 65%, not 64, 65%. Of total carbohydrate or total energy should come from our carbohydrates. And again, we want to focus on complex carbohydrates, whole grains, fiber-rich foods. It is possible to consume too much carbohydrate, so there's no UL for carbohydrates, but consuming too much can cause it to be stored as fat. So our glycogen storage is limited. Again, we can only store so much, but those stores are quickly depleted. So any excess carbohydrate that is consumed will be stored as fat because our fat storage is pretty much unlimited. Our last topic in this segment is diabetes. So the prevalence of diabetes has increased in the United States. Over 26 million people have diabetes, and another 79 million people have pre-diabetes. And a lot of these people may not know. There are a lot of dangers of diabetes. It's very costly in terms of healthcare. So excess glucose can be bad for the body. If someone has low blood glucose for a long time, this can be bad. It can cause circulation problems, and it also increases the risk of heart disease and stroke. There are two main types of diabetes, type 1 and type 2. Generally, type 2, it's diagnosed less than 30 years of age, whereas type 2 used to be greater than 40. We're seeing it being diagnosed much earlier, with obesity being one of the causing factors of that. The main differences are that type 1 requires insulin, and type 2 can often be managed with diet and exercise lifestyle intake. So make sure to review this in your textbook as well. Because I lastly would like to focus on how do we manage diabetes. So the goal is to keep blood glucose levels in normal range to prevent hypoglycemia or low blood sugar. So proper diet is very important. So controlled carbohydrate intake. So making sure they hit that 45 to 65% of their total calorie intake, and then spacing that calorie or the carbohydrate intake throughout the day. So they're not consuming all 65% of their carbohydrate intake at night. They're consuming it equally throughout the day. Exercise is also very important. However, if someone is taking insulin, this could, affect dosages because exercise heightens cell sensitivity to insulin. Of course, monitoring glucose to make sure everything is running smoothly. So we would look at things like the hemoglobin A1C, and the medication may be necessary for some individuals. A 5 to 7% weight loss by people who are overweight or obese can help to reduce the risk of type 2 diabetes, and it can also help for individuals that are already diabetic. This can help to better control or even get rid of the disease. So type 2 diabetes is preventable, and it is treatable as well. So make sure to review the management of diabetes in your text as well.